In this case, we're simplifying radical products. Rather than finding the product and then simplifying, I think it's much simpler to simplify first, eliminating as many ones as we can. So of course, I've got y squared times y is going to be y cubed, but y cubed divided by y cubed makes 1. So I'm going to eliminate y cubed with y cubed. X cubed divided by x, well, x cubed is the same as 8 times x squared times y times 7 times x to the 4th, divide by 2 times x times 4. Well, now I've got another 1, x divided by x, and of course 2 times 4 is 8. So once I've done all my simplifying, then I'm going to find my product. X squared times x to the 4th is x to the 6th. I'm going to put constants in front though. 7x to the 6th y. And I have no more denominator. Again, I want to simplify first, so I'm going to factor first. This first expression I could factor out of 3x and get 1 minus x. This second expression factors into x plus 5 times x minus 4. In the denominator, let's try and make a straighter line there. In the denominator, I have x plus 5 times x minus 1, and I have 3 times x. So now let's eliminate our 1's. 3x, 3x, x plus 5, x plus 5. These are very close to each other. Notice in this first term, if I factor out a negative 1, then I would have negative 1 plus x. So if I multiply this out, I'd get the same thing. But negative 1 plus x, divide by x minus 1, oops. Now these are equivalent, so those simplify. Let's make those red. And I still have on top my x minus 4. So negative 1 times x minus 4, I could call that negative x plus 4, or better to call it 4 minus x. Again, no more numerator. Okay. In this last one, I've got perfect cube minus perfect cube. I don't know if you know this formula off the top of your head, and it's okay if you don't, but the way this factors is as a minus b times a squared plus ab plus b squared. So, knowing that, I'm going to come down and factor. I've got x plus 2. Notice this is like being in the numerator, so I'm going to factor it up top. It does not factor though. In the denominator, I'm going to have x minus 3. Notice this is the same as x cubed minus 3 cubed times x squared plus 3x plus 9. So following this pattern, oh, I should have left this on top as well. And now I do have terms that cancel. Those are the same. And this is what I'm left with. So again, wanting to answer the question, where is it undefined? So in my first scenario, I am undefined if x or y is equal to 0. So this function in the end, this expression, only exists for x not equal to 0 and y not equal to 0, because that's where it's undefined. Again, looking at the original, my function is undefined if x is negative 5, 1, or 0. So x cannot be 0, negative 5, or 1. And now looking at this original one, clearly x cannot be 3. But I also need the situation where x squared plus 3x plus 9 is equal to 0. Well, let's do a quick check on that. I've got negative b which I don't care about. I care about the discriminant. So my discriminant is b squared minus 4 times a times c. This is always going to be less than 0. Therefore, this has no real roots. So the only place my function is undefined is when x is equal to 3.